Okay, so in order to condense a logarithm that has been expanded, you'll notice that it'll have plus or minus in it. And also, all of your exponents will be big numbers in the front. So that should be your very first order of business. Take the big number in the front and bring it up as an exponent. So now we'll have 2 to the third and x minus 4. So since we have addition, to condense this, we're going to take the log and we're going to pull it to the front. And then we're going to take our 2 to the third and our x minus 4, and we're going to multiply those two together because addition condenses to multiplication. Now we know that 2 to the third power is 2 times 2 is 4, and 4 times 2 is 8. So we're going to have 8 times x minus 4. Now a quick distribute will give us the common log, because this will be log base 10 of 8x minus 32. And I'm going to put that in parentheses because it's all going together, and we don't want us to think that we're doing log of 8x and then minus 32 outside the function. So we're going to put 8x minus 32 in a parenthesis. Now right here, first things first, we have the big 1/2, so we're going to bring it up as a 1/2. So we have log base 5. Pull your log base 5 to the front, because when you condense, you should only have 1. Since we have subtraction, we're going to change this to division. Whatever is in front of the subtraction sign will be the numerator, and whatever is behind the subtraction sign will be the denominator. Now, since we have a fractional exponent, we know that this is the same thing as the square root of 324. Now, we need to figure out what the square root of 324 is, so we have to ask ourselves, what do we multiply times itself to get 324? Now, in this case, that's going to be 18. So we'll have 18 over 2, which is 9. So that'll leave us with log base 5 of 9 as our condensed expression. Okay, on our next one, we have the big number 3, so we're going to change this to 6 to the third, and then we have big number 3/2, so we'll change that to an exponent of 3/2. So take your natural log, which is ln, and pull it to the front, and since we have subtraction, we're going to change it to division. So my 6 to the third power will go on the top, and my 4 to the 3/2 will go on bottom. Now we need to multiply out 6 to the third. 6 times 6 is 36, and 36 times 6 is 216. Now 4 to the 3/2, let's look up here to the top. Now whatever the denominator is, remember that is the root of your index, okay? So this is going to be a square root, and then this will be your radicand. Whatever the numerator is, that's going to be your exponent. So we can take the square root of 4, which is 2, and then we're going to raise it to the third power. 2 times 2 is 4, and 4 times 2 is 8. So what I have is 216 over 8. Let's go ahead and divide that out, and that'll give me 27. So what my solution is going to be the natural log of whatever I got, which is 27. And that's my condensed single logarithm. Now when we expand, we're going in the opposite direction. So looking at this, all of this is multiplied together, but there's an exponent on the outside. So what I'm going to do first is power to a power. When you have an exponent raised to another exponent, remember you multiply those exponents together. So I'll have 2 times 3 is 6, and 5 times 3 is 15. Now, since we have multiplication here, I'm going to take and I'm going to do log base 3 of my x to the 6th first. And wherever the time sign is, I'm going to replace it with plus. And then I'll do a log base 3 with the other part of the product, which is y to the 15th. Now, when you expand, you don't want exponents. So we'll take our exponents and we'll bring those to the front of each of our logs. So that'll be big 6 times log base 3 of x plus big 15 times log base 3 of y. So when it's expanded, I've changed multiplication to addition. Each part of my product got its very own log base 3, and all of my exponents came to the front as big numbers multiplied to my logarithms. Now in number 27, even though it's a natural log, we're still going to do the same thing. We're going to raise each part to this 4th power. So we have the natural log of 2 to the 4th power over 3 times 4, which is 12. Okay, so I know that I can multiply this out and get 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16 over a to the 12th. And then I'm going to take each natural log and I'm going to put it with the numerator and the denominator. So I'll get the natural log of 16, and wherever I have my division is where my minus sign goes, and I'll have the natural log of a to the 12th. The natural log of 16 is going to stay the natural log of 16. But if you'll look at that natural log of a to the 12th, once again, we have an exponent there. So what we want to do is we want to get that exponent and we want to bring it to the front as a big number. So minus 12 times the natural log of a. So when we expand, division changes to subtraction. Okay, our exponents come to the front as big numbers, and each part, numerator and denominator, gets its own logarithm. Now, when you do a radical, you have got to change the radical to its fraction exponent. So put p to the 3rd and q to the 10th in a parenthesis. Now, since you're taking the square root, we're going to raise this whole thing to the 1/2 power. So now I'm going to do power to a power. So 3 times 1/2 is going to give me 3/2. Then 10 times 1/2, 2 will go into 10 5 times. That's going to give me q to the 5th. So now, since I'm multiplying, I'm going to do log base 4 of p to the 3/2. And where my product is, that's where my plus sign will go. And then the other part of the product will get its own log base 4 of q to the 5th. So we're almost there. When you expand, you shouldn't have any exponents. So let's bring those both to the front as big numbers. So that'll be 3/2 times log base 4 of p. And then plus, bring the 5 to the front, 5 times log base 4 of q. And that is my expanded form.